Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to multiply and divide rational expressions. Alright, let's take a look at the first example. Instructions are for us to simplify each expression. Okay, simplify each expression. So let's say we have 6x divided by 72x to the fourth power divided by 6x divided by 2x plus 4. Now when we're dividing rational expressions or algebraic fractions, the first thing we want to do is express it as a product problem. Okay? So what we're going to do is we're going to drop, change, and flip. Okay, drop, change, flip is the process that enables us to change a division problem of two fractions into a multiplication problem. It just basically relies on the fact that when you're dividing, it is the same thing as multiplying the dividend by the reciprocal of the divisor. Alright, so we'll drop this algebraic fraction, the dividend, and divide it by 72x to the fourth. And then we're going to change our division into a times. Okay, drop, change, and then we'll reciprocate this rational expression right here and express it as 2x plus 4 divided by 6x. Now what we're going to do is multiply horizontally. Okay, so we have 6x multiplied by 2x plus 4 divided by the denominator, which is 72x to the fourth multiplied by 6x. Now what we are going to do is go ahead and decompose each term that's expressed as a product of factors. Decompose each term and then we can reduce common factors. Okay, what you want to keep in mind is that when you have a binomial expression, it is a package. You cannot cancel any of the terms in there with another term separately. If you want to reduce a binomial expression, you reduce the whole thing as a package. Now let's go ahead and start with 6x or 6. If we want to decompose 6 using product of primes only, 6 is 2 times 3. Alright, so 6x will be 2 times 3 times x for 6x. Now how about this binomial right here, 2x plus 4? Can it be factored further? And the answer is yes. We have 2 times x plus 2 times 2. The decomposition of 4. There is a greatest common factor that can be extracted here. You can factor out 2 and you're left with x plus 2. So this quantity 2x plus 4 can be written as 2 times x plus 2 divided by 72. Let's go ahead and decompose that. We want to express 72 as a product of primes. Okay, so 72 is even, so we know 2 goes into 72 36 times. 2 goes into 36 18 times. Can still go further. 2 goes into 18 9 times. 3 goes into 9 3 times. So 72 is basically 2 times 2 times 2, 3 2's times 3 times 3. We're going to insert this prime factor decomposition of 72 right into the spot right here. So we'll have 2 times 2 times 2, that's 8, times 3, that's 24, times another 3, that gives you 72. There we have x to the 4, so we're just going to write it as a product of 4 x's. 1, 2, 3, 4. Now what is the prime factor decomposition of 6x? Well, We had already decomposed it earlier, right? So we can write it again. It's just 2 times 3 times x. Now, if you have noticed earlier, we could have just canceled out this 6x and that 6x. Still the same thing. Alright, you can cancel out diagonally or vertically. So let's go ahead and reduce. Cancel out common factors. 2 goes here once, 2 goes here once. Any other 2's that can be divided out, 2 goes into 2 once, and 2 goes into 2 once. How about 3? We have a 3 upstairs. 3 goes here once, and 3 goes here once. And then the x's, x goes here once, and x goes here once. Notice we're canceling out factors, okay, not sums or differences. Now take a look at x plus 2. This is a big mistake most students make that you want to avoid. Most individuals believe that you can cancel out those x's like that. That is incorrect. What's the problem with that? X has been added to 2. The only way you can separate x plus 2 is by subtracting x or subtracting 2, because the inverse of addition is subtraction. Alright? So you can only cancel out x plus 2 as a package with another. Let's say we had another x plus 2 here. Then we can cancel them as a package. Otherwise, you cannot separate them for cancellation by division. Okay, because this is an addition operation. So we have to leave that intact just like that. There's no other factors in the numerator to be canceled out. So we'll simply multiply the denominator and put the numerator x plus 2 over it. Okay, so we have x plus 2 in the numerator, x plus 2 divided by, what do we have in the denominator? We have 2 times 3, which is 6, times 2 times 3, another 6. 6 times 6 is 36. So we have 36, x to the 1, 2, 3, 4. 36x to the 4th power is our final result. Now, if you have any questions about the process we went through in coming up with the simplified form of this quotient of rationals, just place your questions or comments in the comment section below, and we'll be more than glad to address it. Okay, let's take a look at question 2. Now, what if we were asked to find the quotient of the following expressions? So n squared minus 4n minus 60. What if we have that divided by 6? This fraction divided by the rational expression 2n minus 20 divided by 42. Now what we're going to do is drop, change, flip. Okay, we're going to drop this fraction right here, n squared minus 4n minus 60 divided by 6, and then we're going to multiply, change division to a multiply, and then we're going to flip this. We're going to reciprocate this this term right here. So if we reciprocate it, we'll end up with 42 divided by 2n minus 20. Now, it wasn't a rational expression before, but now it is because you have a variable in the denominator. Okay, so now what we're going to do is express it as a product. So we have the quantity n squared minus 4n minus 60 times 42. Now that divided by 6 times 2n minus 20. Okay? Now what we're going to do next is we're going to proceed to decompose monomials and factor polynomial expressions with more than one term. Let's start with this trinomial right here. We have n squared minus 4n minus 60. Since we have a trinomial, we can factor using the x game or the AC method. We have negative 60, and then for b we have negative 4. So what two numbers multiply to give you negative 60 and add to give you negative 4? Negative 10 and 6 works. If we test it, negative 10 times 6 is negative 60, and negative 10 plus 6 is negative 4. So since a is equal to 1, we no need to factor by grouping. Okay, no need to factor by grouping. Anytime a is equal to 1, you can jump straight to the factored state. So here we can just skip to the factored state, which is n minus 10 times n plus 6. Now, if you were not aware of the fact that a is equal to 1 and you proceeded to factor by grouping, you will still end up with the same result, but it just takes more time. Okay, so here we have this quadratic trinomial in its factored state is n times 10 times n plus 6. Now let's direct our attention to 42, this monomial right here. Let's decompose it. If we decompose that, we'll have 2 goes into 42 21 times. 3 goes into 21 7 times. So the decomposed form of 42 is 2 times 3, which is 6, times 7. So we're going to put it right here, times 2 times 3 times 7. Now we're going to go ahead and direct our attention to the denominator. 6, we already decomposed this in number 1, remember, 2 times 3. That's the prime factor decomposition of 6. So we replace 6 with 2 times 3. Now we'll direct attention to the second denominator factor, the quantity 2n minus 20. Can we factor this? Well, let's express it as 2 times n minus, if you decompose 20, you have 2 times 2, which is 4 times 5, which is 20. Now you can see that 2 and 2's are common, so we can factor that out. 2 times n minus 10. Okay? So in place of the quantity 2n minus 20, we're going to insert 2 times n minus 10. Now let's go ahead and see if there are common factors we can reduce in the numerator and the denominator. Can we cancel out or divide out n minus 10 and n minus 10? The answer is yes. Remember, we talked about sum or difference of terms as packages. They go and come together. So if we want to divide out n minus 10, we must have another n minus 10 in the denominator to divide it out with. How about 2's? We have a 2 in the numerator. Divide that with this 2 here. And then 3 goes here once, and 3 goes here once. And that's basically it. We don't have any common factors in the numerator and the denominator to factor out. So we'll simply just express our remaining terms as product, 7 times n plus 6. That divided by 2. Alright? So there goes your final answer for question number 2. Alright, now let's take a look at a product example for question 3. What if we were to find the product of 1 over 2x minus 16 times x squared minus 9x plus 8. That divided by x squared minus 4x. Okay, so no need to drop change flip here since we already have a product. We're just going to first of all multiply. When we multiply here, we'll simply have x squared minus 9x plus 8. 1 is a multiplicative identity, which means that when you multiply a number by 1, it doesn't change. So we just end up with that in the numerator. And in the denominator, we have 2x minus 16 times the quadratic binomial x squared minus 4x. Now let's start with the numerator. Let's go ahead and factor that. We have x squared minus 9x plus 8. We're going to factor this quadratic trinomial using the x game. Now, AC goes on the top. AC is 8, and B is negative 9. Now, what two numbers multiply to give you 8 and add to give you negative 9? We can use negative 1 and negative 8. Now, what is the sign of what is the value of a here? A is 1. So since a is equal to 1, no need to factor by grouping. We can just jump straight to the factored state. Factored state is going to be x minus 1 times x minus 8. Okay, now let's direct our attention to the denominator. We have two binomials there. Let's start with 2x minus 16. Is there a greatest common factor I can extract here? Well, let's decompose. 2 times x minus 16 is 2 times 2, which is 4 times 2, which is 8 times 2, which is 16. 2 and 2 are common factors. They can be factored out, which leaves us with x minus 2 times 2 times 2 is 8. Oh, let me go ahead and insert my factored expressions while I'm at it. So the numerator is x minus 1 times x minus 8. And in the denominator, 2x minus 16 is 2x minus 8 times, let's go ahead and take a look at that one there, getting ahead of ourselves. X squared minus 4x. So we have x squared minus 4x. We can go ahead and see if we can factor out a greatest common factor. X times x minus 4 is 2 times 2 times x. Now we can pull out an x, and then we'll have x times x minus 4. Okay, now let's go ahead and insert that there. In the denominator, we have x times x minus 4. Now that we've completely factored the numerator and the denominator, let's see if there are common factors that can be divided out. Alright, so if you notice, we have x minus 8 here and x minus 8. Identical packages, so we can divide them out like that, x minus 8 and x minus 8. And that gives us our final answer, which is x minus 1 in the numerator divided by 2x times the quantity x minus 4. So there goes your final result. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your study of rational expressions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to respond. Do subscribe to our channel for updates to other tutorials such as this. We always update new clips to our YouTube page on a consistent basis. More tutorials can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.